Alright guys, as we get started on this part of class, I just want to go through with you. The next part we're going to take a look at chapters 10 through 12, which sounds like a lot. However, we're only going to be in chapter 10 for about 3 minutes. I just want to show you guys something real quick in chapter 10, and then chapter 11 and 12 we use the same formula in both chapters, so that's actually pretty quick too. So go ahead and take a look at chapter 10. I want to show you guys page 220 in chapter 10. At the bottom of page 220, what we're looking at in chapter 10 is we're looking at what's called the Apothecary Measurement. It's the apothecary system is a system of measurement that just really isn't used that much anymore. It's just kind of an outdated system. As you can see at the bottom of page 220, we're seeing a few new units. The one that's definitely the newest one for us down there is called grains. Other units that you guys might see that are part of the apothecary system, you might see drams somewhere. Sometimes they might show drams on a medicine cup. It's just part of a different system of measurement. And grains is something that I want to show you guys real quickly, just because it comes up in the next chapter, and you may occasionally see it in the field. Just somebody who's kind of used to old school methods, they may choose to use grains. Now I know it says grain I, as you guys can see. What it's doing, it says grain I is equal to 60 or 65 milligrams. We're going to stick with 60. Definitely the easiest thing to stick with there. It's the most common one to use with grains there. But what grains, a lot of times they use Roman numerals to measure grains, and they put it behind the unit grains. I will not give you guys any Roman numerals. I is the Roman numeral for 1, so really this translates out to just say that 1 grain is equal to 60 milligrams. And the reason why I show you this is because what that means is anytime you're given a certain number of grains, then all you need to do to convert it to milligrams is simply just multiply it by 60. So what I mean by that is, say if I have 4 grains, then again, if I have 4 times the amount of this, then that means I just have 4 times the amount of this. 1 grain is 60 milligrams, so therefore 2 grains would be 120, 3 grains would be 180, so 4 would be 240. So again, every time we're just multiplying by 60. It's the same thing with what we did in chapter 4. In that in chapter 4, when we were using those equivalents, if we said that I know that 1 grain, I'll just abbreviate here, is 60 milligrams, we can use that as our known. And if we're trying to convert 4 grains to X amount of milligrams, we very well could do that too. And again, to solve that, we take 60 times 4 divided by 1. So again, we still get 240 milligrams. But to save yourself the trouble on that every single time, no matter what this number is, you'll notice that every single time we're just going to multiply it by 60 in order to convert that to milligrams. I show you that real quickly because the most common unit that you guys are going to see in dosages, as we get into our next couple chapters with dosage calculations, is milligrams. So anytime, say, a doctor orders a certain amount of grains, all we need to do to figure out, because probably that medication is going to come in milligrams, all we're going to need to do is multiply that by 60 to figure out what we need to get that into milligrams. So we'll see that come up in the next chapter. I'll show you guys how we approach those. But I wanted to just show you real quickly that that's where that comes from. It is an apothecary unit. Even if we run into some dosage even if we run into some Roman numerals in those dosage calculations, you will never get one from me, and I will explain to you guys as we go through these practice problems that those will be used as numbers, not Roman numerals. So that's the only thing I wanted to show you guys in chapter 10. I wanted to just show you guys, okay, if you see grains, remember, times 60. And not to be confused with grams, what we just looked at with our metrics. Metrics, grams is a metric unit, and if I needed to convert that to milligrams, remember grams to milligrams. So again, not to be confused with grains. Grams to milligrams, remember using our metric chart, is either 3 movements to the right, because grams, and then remember here's deci, centi, milli. Grams to milligrams is 3 places to the right. Whereas, or again, for those of you guys using that stair-step method, that was the same thing as times 1,000 since we're going down one step. But for grains to milligrams, remember that's that old school apothecary unit. All we need to do here is times 60. So anytime you see grains, we multiply by 60 to convert that to milligrams. You guys will see where that's going to come up as we get into these dosage calculations. So let's go ahead and let's take a look at those dosage calculations. Now getting to chapter 11. Chapter 11 begins on page 235, but we're actually going to start on page 238. So go to page 238 in your book. I'm going to show you guys just how easy these dosage calculations can be by doing an example first, and then I'm going to show you guys the formula that's on the top of page 238 and 239. So just giving you an example. Let's say, we're in a, doctor's office, we're working for a doctor, and the doctor says, okay, the patient that we're working with right now needs to take 50 milligrams of some drug. Okay, we'll just call it Zyrtec. Maybe he has allergies. 50 milligrams. We look on the label for Zyrtec, and it says that Zyrtec comes in 10 milligram tablets. 10 milligram tablets. So if the doctor ordered 50 milligrams of this drug, and it comes in 10 milligram tablets, well, how many tablets does that patient need to take? Hopefully you guys can have done that in your head, and you guys are saying 5, that they would take 5 tablets, and you're exactly right. Now there's an easy way to do this. Now this is one that we can do in our head, and there are many that we'll be able to do in our head. And if you can do them in your head, I would much rather you guys do that. But for those of you guys that or when we run across some that may not be as easy to do in our head, there is a formula that we can follow for these types of equations. At the top of page 238, it gives us these symbols, D, H, and Q. And at the top of page 239, it shows us how we can use those symbols in a formula. So I'm going to do the same exact question that we just did, but I'm going to put them into this formula here. Into this formula that says, it says D divided by H times Q. And again, like I said, at the top of page 238, it tells us what these things stand for. D up here stands for the dosage that has been ordered. So you can remember that for D for dosage, or D for maybe doctor's order, however you guys want to remember that, or the desired. Sometimes people remember that as what's desired. Whereas H is also a dosage, but H is the dosage that we have on hand. So in our example, guys, the D was the doctor's order. That was the 50 milligrams. Whereas H was the dosage that we had on hand. That Zyrtec came as 10 milligrams in each tablet. The next letter that you guys have, that symbol, that last one is Q. Q stands for quantity that dosage comes in. So if you guys remember when we talked about Zyrtec, I said that it was 10 milligrams per each tablet. So meaning for every one tablet that somebody would take of that Zyrtec, they would get the 10 milligrams of that drug. So the quantity in our example was one tablet. I'll write that here. One tab. Sorry, that handwriting's terrible. One tab is what that says there. So H and Q in this formula here, those are always going to be listed together in the problem. It's the dosage that we have on hand, and Q stands for the quantity that it comes in. In most cases, when it's a medication that comes in tablets or capsules, your quantity is typically going to be 1, because it's always for every 1 tablet is how much medication is in each tablet. Whereas every once in a while that might change when we get to liquid medicines, because the dosage might be per 5 milliliters or 2 milliliters or something like that. And we'll get to some samples where I will show you guys that. So again, you guys did this one in your head, but what you did is you took 50 divided by 10, and then you multiplied that by 1, and again that gave us the answer of 5 tablets. So one thing I want to point out on this, you'll notice that in this equation, just looking at what's written in blue, that was the problem that we had before we got the answer. The answer is what I have there written in red. But I want to point out here that in that blue, we have 50 milligrams divided by 10 milligrams. We're multiplying it by 1 tablet. Looking at the 3 units that I have in this equation, I have milligrams divided by milligrams times tablets. You'll notice that the unit of my answer is tablets, and that was the unit of the quantity. I want that to be the case. I want that to be, those two to be the same. So what makes sense is whatever our quantity is will always be whatever our answer is. So in this case, the medication comes in tablets, so therefore I need to give that patient tablets, and that makes sense. So really, and the reason why I'm saying this is because the other 2 units in this problem, the D and the H, are both milligrams. I want them to be the same because when they're the same there and they're opposite numerator denominator, what happens is they cancel one another out by being the same, and that leaves me at the end of that equation with only tablets left over, which is why my answer can then be in tablets as well. So my one stipulation for using this equation, now let me clear this out a little bit so I can show you guys this a little bit clearer. Go away. Okay. Showing you guys this equation again. D divided by H times Q. I'm going to leave this up here as we go through some sample problems. Our one stipulation for this, and just kind of a little side note over here, D and H have to be the same unit. They must be the same unit. Well, that's horrible handwriting there. It's hard to write on this iPad. D and H must be the same, and it should be the same unit. Let's write that, same unit. So what that means is if, say, doctor orders a medication in grams and that medication comes in milligrams, we're going to have to do some switching up. It's one thing with what we just saw, where in Zyrtec, doctor orders so many milligrams of that drug. Well, since it came in 10 milligram tablets, we knew that we needed to give them 5 tablets. We didn't have to do anything. But I'll show you guys when we come across some examples, I'll show you guys that we're going to need to do some changing when we come across those. So let's actually do some examples. Let's go over to page 241. And on page 241, let's look through some samples here. Number 1, in practice 1, there is very similar to the first one that we did, that the order dose is 30 milligrams. That medication comes in 10 milligrams, so there's our H. And it's per tablet, so in other words, per 1 tablet, so our quantity is assumed to be 1 in that case. So very similar to our last example, we would have just taken 30 divided by 1, or divided by 10 times 1. So we would get 3 on that one, on number 1. Let's take a look at another one. Looking at number 2. Number 2, we have 1 milligram as our order dose. The dosage that we have is 5 milligrams per milliliter. So what that means is for every 1 milliliter that a patient takes of that medication, they get 5 milligrams of drug. Well, they don't need a full 5 milligrams of drug. Because of that, they're not going to take the whole milliliter. That makes sense. So what's going to happen is you can just plug that into the dosage formula as 1 milligram divided by dosage on hand times, and again, per milliliter, that just means 1 is assumed there. So we take 1 divided by 5, which is 0.2, times 1 is still 0.2. So they would only have to take 0.2 milliliters in order to get what they need. They only need 1 milligram of that drug, so that's why they just take that. Okay? Very similar, number 3, what's ordered is 1,500 milligrams. We have 500 milligrams per tablet. So looking at that one, you guys might be able to just look at that one and see that they would only need 3 tablets. But if you plugged it into a dosage formula, it'd be 1,500 divided by 500 times 1. Let's see, let's move down to number 6. I want to show you guys number 6. I want to show you guys what I meant when something happens when the doctor's order is not the same. Now let me plug these into the dosage formula first. Looking at number 6, you can see that the doctor has ordered 0.25 grams. Let me just write that out here so you can see that's grams. And that medication comes in 50 milligrams per 2 milliliters. There's another case, another thing we're going to have to pay attention here, that that it is per 2 milliliters, so we can't forget to multiply by 2 there. Okay, so when this happens, what we're looking at is doctor's order is in grams, and that medication comes in milligrams. So we're going to have to do some switching around here. When that's the case, I can't just divide these, because remember, D and H have to be the same unit. Don't forget that. They need to be the same unit. So what happens in these types of equations, when this happens, all you have to do is change one to the other. What that means is I could take that, doctor's order in grams and convert it into milligrams. And if I did that, then therefore they would both be in milligrams and we're good to go. And I know how to do that because we did that in our metrics chapter in the last chapter we looked at. But I could do the opposite too. I could take this unit down here in milligrams and convert that to grams, and then therefore they'd both be in grams. And I'm going to end up getting the same answer either way. What I'll tell you guys with this though, typically the most common unit that you guys will see, as you guys can see in numbers 1 through 5 in just this section, you can see everything was in milligrams. So I am in the habit, and I recommend it to you guys too because it might be a little bit easier, is to get everything into milligrams. So let me put this back on the board here. 0.25 grams over 50 milligrams per 2 milliliters. There's D, H, and Q from number 6. However, since doctor's order, or D, is in grams and H is in milligrams, I have to change. So, like I said, I'm in the habit of getting everything into milligrams. So I'm going to go ahead and take that doctor's order from grams and convert it into milligrams. Remember how we do that? If we're using the metric chart, that kilo, hecto, deca, base, deci, centi, milli chart, that one, base to milli, remember, is 3 places to the right. So taking this decimal and 0.25, just showing you guys down here, 3 places to the right would be 250. And for those of you guys using the stair-step method chart, 0.25 times 1,000 is also just 250. So what that means is, and we're not changing the doctor's order at all, we're just saying, hey, 0.25 grams is the exact same thing as 250 milligrams. And since that's what that medication comes in, we need to see it as that. But that allows us to now complete this problem. Once it's in the same unit, now I can go ahead and divide that out. So 250 divided by 50 is 5. Taking that and multiplying by 2, the answer there would be 10 milliliters. That's what they need to take of that drug. So like I said, we're not changing the doctor's order at all. We're just simply getting it to where we can see it so that it matches the other. Again, it's not changing it. We're just looking at it in a different unit. It's the same thing with like what we did in the household system. That 1 cup is the exact same thing as 8 ounces. So if I just needed to see cups and ounces, I would look at it as 8 instead. And that's what we're seeing here, is it's just one and the same. The same thing happens down there in number 8. That in number 8, if I have doctor's order as 0.1 gram, and that medication comes in 25 milligrams per 2 milliliters, we'd have to do the same thing. And again, like I said, it doesn't matter which one you change, just as long as you change one to match the other. But again, I'm typically in the habit of changing everything into milligrams. So that means this is not in the right unit, so I'm going to adjust it. H is in the unit I need it to be in, so I'm not going to change anything about it. I just changed that grams to milligrams up there in the doctor's order. So by either moving that decimal 3 places to the right, again, that's what grams to milligrams is on that metric chart, or times 1,000. So that would be 100 milligrams. So we'd end up with 100 divided by 25, which is 4, times 2, answer here would be 8 milliliters. Again, the unit of my answer is always whatever the unit of my quantity is. So no matter what, we always want D and H to be the same unit. Going over to the next page, on page 242, in those practice problems, we see a lot of similarities. We're going to see like number 1 and 2 are some of the ones that we just did. Number 3, just the same. Doctor orders grams, but that medication comes in milligrams, so we're going to have to do some switching around on those. Those are good practice problems there. But I want to point out number 4. Number 4 is very strange. That says grains X. what in the heck is grains X? Doctor orders grains X. Like I said, guys, when we looked at grains are a little weird, and sometimes they're measured using Roman numerals. X is the Roman numeral for 10. So you guys would never see that Roman numeral for me. How I would list that if I gave you grains on a test is I would actually use the number 10 in that case. So the doctor orders 10 grains, but on number 4, that medication comes in milligrams. Once again, seeing that real common unit comes in milligrams. So 180 milligrams per 1 milliliter there. So again, we've got to get everything in the same unit. Once again, it doesn't matter which one you change. However, getting everything into that common unit that we talked about, I'm used to kind of getting everything into milligrams, and we know how to convert grains to milligrams. We just learned that as in that few minutes that we took a look at chapter 10. In chapter 10, we learned that we can convert grains to milligrams by simply just multiplying it by 60. Every single time, grains to milligrams, just times 60. So we would take that 10, multiply it by 60. That's going to give us 600. And so now that they're both in milligrams, now I can go ahead and divide. I'll take 600 divided by 180, which gives us 3.3 repeating. We can just round that off, and then times 1 is still 3.3. So that person would just need to take 3.3 milliliters of that drug. And that works for all of those. You know, again, number 6 and 7, very similar. You have to convert, similar to what we did on the previous page. Again, not to confuse grains and grams. On number 6 and 7, the order dose is in grams, which is what we did on the previous page there, where we had to convert those metric units by either moving 3 places to the right or times 1,000. That's how we get grams to milligrams. Now, number 8, grains, ISS is the abbreviation or the Roman numeral for 1, and then SS means half. So that is 1.5. So you could just take 1.5 times 60 in that case, and that would convert that to 90 milligrams. So really the doctor's order is 90 milligrams, and we have 30 milligrams per tablet, so they're on number 8. They would just take 3 tablets. So just so you guys know that. Over on the top of the next page, I'm not going to give you guys grains that have fractions, so you don't need to worry about that. Although that would be super easy because we know how to convert fractions into decimals. They give us 1/8 of a grain. 1 divided by 8, if we're turning that into a decimal, remember, is 0.125. So really they have they've ordered 0.125 grains. And then again, to get that into milligrams, we simply just multiply that by 60. And so what that comes out to be is 7.5 milligrams. So really, the doctor has ordered 7.5 milligrams. That medication comes as 7.5 milligrams per tablet. So therefore, they would just have to take 1 tablet. So you could do that if you were given a problem like that, but I'm going to avoid any fraction, so you don't need to worry about that. So there's a lot of practice problems that you can do in this chapter. There's a ton more on page 243. I want to point out some of the questions on page 244. You may see some like this. I know we didn't touch too much on chapter 9, where we were reading medication labels. However, I think a lot of you guys probably have plenty of practice reading medication labels and seeing how to find the dosage calculation. The dosage on a medication label. Pretty easy to spot. Like on number 1 on page 244 in practice 3, if I have where the doctor has ordered that Galepside extended release tablet, you can see in the question it says that the doctor has ordered 10 milligrams once a day. Well, looking on that label, you can see that they're tablets. They're those, it says that it's 100 tablets, so it is tablets. And it says on there in red, it says that there are 10 milligrams in each of those tablets. That's what that means. So therefore, our H in number 1 would be 10 milligrams per, and then our quantity of 1 tablet. So therefore, that person would only have to take 1 tablet. Same thing goes with number 2, where the order dose, you can see in the question, says 20 milligrams. That particular medication also comes in 10 milligram tablets, so therefore they would take 2. So it's just reading it off the label. It's just reading that and seeing. All of these are either tablets or capsules, and so you can see that the red on all of these labels on page 244 and 245 all of those are per tablet, so your quantity is 1. The only time you're going to see a change of your quantity, if you guys flip over to number 8 on page 246, flip over to the next page, it says that the client receives a medication order for gabapentin oral solution, 500 milligrams per dose 3 times a day. First, don't worry about the fact that it says 3 times a day. I'm only focusing on what that order dose is. So I'm looking at that 500 milligrams. Then, when we look at the label, you'll notice that it says this. It says 250 milligrams / 5 milliliters. What that means is, for every 5 milliliters that a patient takes of that liquid, of that oral solution, they're going to get a pure dosage of 250 milligrams. Our patient needs 500. They need double that. So they're going to end up taking double the amount of milliliters. So you guys are probably thinking, okay, so they need 10. Perfect. You got it right. But how we can put that into the dosage formula, order dose again is 500. Our H is 250 milligrams. And our Q would be 5 milliliters there in number 8. So we would just take 500 divided by 250, which is 2. Multiplying that by 5 would give us 10 milliliters. So that's what they need to take in this problem. So just kind of an FYI, you might get something like that on next week's test as well. Just be prepared to, instead of just be given the H and the Q, the supply dosage there, just maybe know how to take a look at that on a medication label and see, and know how to find your H and your Q. So that's where we take a look at it in chapter 11. Chapter 12 actually uses the exact same formula. We're still using that D divided by H times Q formula, but we might be applying it in a little bit different ways. In chapter 12, if you guys look at that on page 253, chapter 12 you can see is titled parenteral dosage. What parenteral means is medications that are given by injection. So what we looked at in chapter 11 just now, those were all oral dosages, things that you take by mouth. So tablets, liquids that you can just swallow, those were all oral medications. Parenteral, all of these are going to be given by injection. So you're going to see terms like vial, IVs in this chapter, anything that's going to be given that way. So on page 253, you even see some of the abbreviations on that chart, in that blue chart that says route, abbreviation, entry point. It just tells us there are different ways that we can give parenteral medications. ID just means intradermal, which is into the dermal layer of our skin. IM is intramuscular, so we're going a little bit deeper, and that type of injection needs to go into the muscle. IV is given intravenously, which means that it's given in a vein. It goes directly into the patient's bloodstream. And sub-Q means subcutaneous, so it goes into the layer that's just underneath our dermis and our skin, so between our skin and our muscle. So hopefully some of those terms are familiar for you guys, for those of you guys who have had anatomy. So that's how we're given those medications. So they're a little bit different, and they're going to be a little bit more specific. And one other thing that's a little bit different on these vials that you guys are going to see in this case would be how they're given. So let me show you this. Go over to page 256 in your book, and I want to show you guys a few things as far as a few slight differences as how these problems might be listed for us. On page 256, you guys will see there's a math sense box, that yellow box that's at the top, sort of in the middle of that page. That math sense, that yellow box shows us how some of these problems might be listed. And it's also in that blue box right on top, that instead of just giving us the supply dosage or what we have on hand as so many milligrams per milliliter, instead it may give us these problems as a ratio or as a percent. And that math sense box on page 256 shows us how we can apply these. And let me show you this. What happens is your order dose will always just be given to us. That, so much has been ordered of a particular medication. So say somebody has ordered 2 milligrams of a medication. But we look, and on that vial says it's been given to us as a ratio. It just simply says 1 to 1,000. What does 1 to 1,000 mean? And what it shows us there in that math sense, that ratios such as 2 to 500 converts to 2 grams in 500 milliliters. Every single time, no matter what, and then it even shows us in the middle there that thus 1 to 1,000 translates to 1 gram in 1,000 milliliters of solution. So anytime you're given a ratio in terms of solutions, that ratio represents grams per so many milliliters. So this one is 1 gram, so I'll write this underneath. This is grams per milliliter. Every single time you're given a ratio, always. So in this case, there's our H and there's our Q. So if I were to fill that in right now as D, H, and Q, D is 2 milligrams, H is 1 gram, Q is 1,000 milliliters. It's just the same way of saying 1 gram per 1,000 milliliters. But I want to point out that yes, that first number is in grams. So that may be something we need to be prepared for. Watch out for if our medication is ordered in milligrams, we're going to have to do some switching around. So I'm in the habit of getting everything into milligrams. So since H in this case is in grams, I'm going to change it grams to milligrams, going 3 places to the right, or times 1,000. That gives us 1,000 milligrams. So what I'm going to do to solve this problem, I'm going to take 2 divided by 1,000 times 1,000 leaves us with taking 2 milliliters of this liquid. Anytime you're given a ratio, remember that ratios represent grams to milliliters every single time, no matter what the ratio is. No matter what. If I have a 3 to 8 solution, that's 3 grams per every 8 milliliters. No matter what the ratio is, if I have a 1 to 200 solution, 1 gram per 200 milliliters every single time. So we're going to see a couple examples where we have some ratios in there. Same thing goes if we are given a percent, which is the next part of that math sense box. If let's say, if we've ordered say 2 milligrams again, doctor's just going to give us that we've ordered 2 milligrams of a particular drug, but we have, can't write today. We have, let's say a 5% solution. A 5% solution. Well, what that means is actually going to be very, very similar to our ratios. Thinking about what percents can be out of. Anytime we have a percent, and we talked about this in our percents chapter, that percents are always out of 100. So if I wanted to instead write this as a ratio, I very well could say, well, 5% means 5 to 100. And that is correct, that every time you have a percent, that's the same thing as saying that number out of 100. So thinking about what we just thought about with our ratios, that anytime I have a ratio in terms of solutions, that means I have that many grams per the second number of milliliters. So in this particular problem, we have 2 milligrams as our ordered dose, but our H is 5 grams, and our Q is 100 milliliters. It's just, we just have to remember that anytime we have a percent, that second number is going to be 100. We just have to remember that. But think of it the same way as ratios. And just know that percents are always out of 100, so write it as a ratio first. So again, what we would do is, again, like I said, don't forget that D and H have to be the same unit. So in this case, since our order dose is in milligrams, we're going to have to convert that H to milligrams as well, and that would be 5,000. So we would take 2 divided by 5,000 times 100, and that would give us 0.04. So 0.04 would be our answer here. That's how many milliliters they need of this liquid. So not very much at all. So we'll see a couple examples, but no matter what, if you have a percent, think about what that would be in as a ratio out of 100, and then remember the same thing we saw with our ratios. So a couple examples to take a look at in this chapter. Go over to page 258 like I said, we're going to see a lot of similarities in this chapter, so we're even going to see some of the same things that we saw in chapter 11. Like on number 1 on page 258, they said that we've ordered ephedrine sulfate 12.5 milligrams subcutaneously, so our ordered dose in this case is just 12.5 milligrams. It says that we have a vial labeled ephedrine sulfate 25 milligrams per milliliter, so per 1 milliliter would be times 1. So there's DH and Q. D and H are the same unit, so we would just take 12.5 divided by 25 times 1, and we'd get 0.5 milliliters in that case. So really, very, very similar to what we've seen already. So we're going to see a lot of similarities. You may see something like in number 2, you're seeing where you have to draw it on a syringe. I won't give you any syringes since we didn't touch too deep on that in chapter 9. We didn't cover chapter 9, so I won't give you guys any syringes. So don't worry about that, but it's just showing that these are a little bit different because they're injectable medications instead of oral medications. Another difference that you guys might see, I want you guys to go over to page 260 and look at the top of page 260. And we'll see, like, number 1 says units. If you ever see anything measured in units, don't be thrown off by those units. It's just another way that we measure dosages, and there's no conversion out of units. So if something is ordered in units, then it's going to be given in units. So you'll notice that the ordered dose is 5,000 units, and the heparin label reads that it's 10,000 units per milliliter. So that just means that we would take 5,000 units is what it's given in. And then the H in this case is how it's given is 10,000 units per milliliter, so times 1 milliliter is what we would do there. So 5,000 divided by 10,000 is 0.5, times 1 is still 0.5, so they would take 0.5 milliliters in that case. So getting into the examples that we talked about in that math sense box, number 15 and then number 18 is a great example with that ratio too. But looking at, let's say we look at number 18 first, because number 18 is what we first talked about and how sometimes they might be listed as ratios. Number 18 says that the drug order reads Pristigmin 0.5 milligrams intramuscular. That's what IM stands for, stat, meaning right away. So we're going to take that as our ordered dose. So let me write that in there. Let's see, so it was 0.5 milligrams. I'm going to write that in as our ordered dose. And our H and our Q is going to come from this ratio. So the drug label reads that Pristigmin is 1 to 2,000 solutions. So don't forget, there's our H and our Q, but don't forget in a ratio, 1 to 2,000 means 1 gram per 2,000 milliliters. Every single time. Every time you have a ratio. Now I can't just take 0.5 divided by 1 because remember, D and H have to be the same unit. Milligrams at the top and grams at the bottom, they're not the same unit. So I'm going to have to do some converting. So I'm going to take that 1 gram and convert it to 1,000 milligrams as I've moved 3 places to the right, or times 1,000 for those of you guys who are using your stair-step method. So that will get them to where they're both in milligrams. Now I can go ahead and divide by taking 0.5 divided by 1,000. I'm going to take that and multiply it by 2,000, and my answer here should just be 1. They're going to take 1 milliliter of this liquid, or of this injection. And that's how we would approach that on number 18. So remember what those ratios mean. Don't forget that. And then number 15, very, very, very similar with number 15, lidocaine. There it says that we would need to give lidocaine 200 milligrams, another IM stat, from a vial labeled lidocaine 10%. So again, here's our ordered dose. We've ordered 200 milligrams of lidocaine. But when it says that it comes as a 10% solution, H and Q will come from that 10% solution. But don't forget, and let me write this off to the side, 10% is the same thing as the ratio 10 to 100. Remember, all percents are out of 100. So just as we saw in the previous example with ratios, remember that ratios just simply mean grams per milliliter. So that means that I have 10 grams per 100 milliliters in this case with that lidocaine. But like we did before, since our order dose is in milligrams, I am going to have to change that 10 grams to 10,000 milligrams. Again, I've just moved 3 places to the right or multiplied it by 1,000. And so now that they're both in milligrams, now I can divide it out. So I'm going to take 200 divided by 10,000, and that gives me 0.02. So times 100 would give me 2. My answer here is 2 milliliters. So that's what makes chapter 12 a little bit different, but again, a lot of similarities in both of those. Anytime you're using dosage calculations, it's just easy as long as it's just to plug in the D, H, and Q. I do have some review videos on our dosage calculations, so I'll make sure to get those to you guys if I haven't sent them to you guys already. So make sure you guys watch those to help you guys as you guys are doing your dosage calculations homework and preparing yourself for next week. We will have a quiz on this next week, and if you guys have any questions, just let me know.